Okay, so today we're doing differential equations, which when I was at university I had a book like this thick and took an entire one semester course on differential equations. So we're doing a very little minor beginning part of this, right? So a differential equation is an equation that involves derivatives of an equation that involves derivatives of a function is called a differential equation. General solution involves an arbitrary constant, right? So in other words, we have a derivative, we're going to find the antiderivative, we add on an arbitrary constant, but there may be some initial conditions that lead us to a specific constant, right? And then we're just going to do like 3 examples or 4 examples and be done. No, 3 examples and then that'll be that. So, oftentimes they'll say dy by dx equals. So if you see dy by dx, just feel free to write y prime, right? And then just, actually what I'm going to do is write it as f prime of x and then find f of x. Right? So what's the f of x then? Okay, so that's how I'm going to write the examples. But in the book, you'll obviously written as dy by dx equals blah. Okay, then you can just think of that. That's f prime of x equals blah. What's f of x? And then what have they told me about f of x? There's going to be something about it. Okay, so we'll give you a couple more seconds. We'll pause. And go.
Didn't say anything. Don't argue. It's not an argument.
Okay, so we're given the derivative and we're given an initial condition and we're asked to find a specific function f of x, right? So we start by finding a general function f of x. So if f prime of x, then f of x is the antiderivative, right? So that's going to be x minus, squared, 3x squared. Mind if I do it that way? I mean, I could write 6x squared over 2 if you like, right? But, plus c, which is the general. So that's one of the family of functions. But we know that f of 0 is equal to 8, right? So you can see, if you do f of 0, this will be 0 and this will be 0. So you can see that c is equal to 8. Okay, now I'll show that in a little more detail, right? So we could say, well, f of 0 is equal to 8, which is 0 minus 3 times 0 squared plus c, leaving me with 8 equals c, and then being able to say, so f of x is x minus 3x squared plus 8. Okay, so that's the function f of x. That's it. There's nothing too exciting there, right? So it's basically what we're doing. We're finding the antiderivative, then we're given some information. We put that into the antiderivative, and we work out what the constant c is for that particular example. Okay, 3 more. Okay, what do you want to do to find this antiderivative? Oh, an f of 1 equals 10. So how are we going to handle this? Well, I think best starting point is probably just to say, all right, so this is okay, so now what? Probably the easiest way to handle this okay, now can you do the antiderivative of that? Now that's pretty easy, right? Whereas you look at it, the initial one, it's sort of like, whoa, how am I going to get a root x, and do I have to use the chain rule? No, we're just going to expand it out. Okay, so f of x. So we can cut straight to the chase. Right? That's going to be a 3/2, which means that I have to divide by 2/3, which means I'm going to multiply by 3/2. Right? I'm going to have to. So sorry, that'd be 3/2, meaning I divide by 3/2, so I have to multiply this by 2/3, which is going to give me 4x to the 3/2. So then you multiply it out, you're going to get 12 over 2, which is 6, x to the 1/2. Right? So it's like factoring, you should always check these out. So are you okay with this, or do you want to see written as 6x to the 3/2 over 3/2? Okay, that's okay? Okay. So this one, the 3/2 is going to become 5/2. Means we're going to divide by 5/2 or multiply this by 2/5, which is going to give me plus 2x to the 5/2. Okay, now you're going to take this, 5/2 times 2 is 5, and reduce that x to the 3/2, which is this. Okay, so that's good. So check it out. Right? I mean, it's fairly easy to check out. Plus c. Again, if you need to show more detail, then write it as 5x to the 5/2 divided by 5/2. Use the anti-power rule, which doesn't really exist, but we know what it is, right? It's like add 1 and then divide by that number. Okay, and then make your adjustments, right? Then multiply by the reciprocal and then simplify. So if you if you need to do more or you want to see more, then please do more. Okay, f of 1 equals 10. So 10 is equal to 4 times 1 to the 3/2 plus 2 times 1 to the 5/2 plus c. Well, the 1 really doesn't do much when you raise it to different powers. So c4. C is equal to 4. And f of x is 4x to the 3/2 plus 2x to the 5/2 plus 4. Okay, so that's your specific function because we had an initial condition, right? Initial condition. Okay, questions, comments, concerns? Okay, two more. Do a couple of trig ones. Now let's do one trig one and then we'll be done. Oh no, and then we'll do one more and then we'll be done. So run trig one and then just a question with slightly different wording, right? So the same idea but just some different wording.
Did you see me?
We saw you.
It's a module.
We saw you.
You saw me in my module. Differential.
Yeah, we saw you.
Okay. So what's the antiderivative of 2 cos t, or the derivative of what gives me 2 cos t? 2 sine t. What's the derivative of 2 sine t? 2 cos t. Good. And what's the antiderivative of sec squared, or the derivative of what is secant squared? Tan t. Plus c, right? So some constant. Now we know that f of pi over 3 is equal to 4. All right, hang on. Let's throw t's in here and here, because that just really wouldn't work all that well with x's, right? So I'm going to use t's, and I need to be consistent t. Consistent t. Okay, so f of pi over 3 is 4, right? Or just write it this, right? So 4 is equal to 2 times sine pi over 3 plus the tan of pi over 3 plus c. Okay, the sine of pi over 3, it's not a half, so it's the other one, right? Root 3 over 2 times 2 is root 3. Is that okay? Do you want me to write 2 times root 3 over 2, or is it just writing root 3? It's okay? You can look at it later and you go, where did root 3 come from? That's right. Tan of pi over 3, tan of sine over cos, which is root 3 over 1, so that's just root 3. Plus c, so c must be equal to 4 minus 2 root 3's, right? That's 2 root 3, and then c, subtract 2 root 3 from both sides. So f of t is 2 sine t plus tan t plus 4 minus 2 root 3. Easy peasy. Hopefully on the test, which is when? When's the test? Monday. So Monday. So tomorrow we finish off, we do this same thing, but just with motion equations. And then, yeah, that's it. And we start integrals, integration.
It's all on the test, right? Like
Start integrals on Friday, definitely start integrals on Friday. Given the graph of f,
looking at these two and You suck.
You can still do it.
I just
What did I do?
Okay, so here's the scenario, the last scenario. We have a graph of a function f. It passes through the point 1, 6. The slope of his tangent line at x comma f of x is 2x plus 1, and we're supposed to determine f of 2. Okay, what do we know? F prime of x is? Yeah, okay, so the slope of the tangent line is the derivative, right? So f prime of x is 2x plus 1. So what's f of x? That's going to be x squared plus x plus c, right? And you should check that. Derivative of x squared is 2x, and derivative of x is 1, and derivative of c is 0. Okay, it's good, so we found that. Now what do we know?
That y is equal to 6 when x is equal to 1.
Yeah, y is equal to 6 when x is equal to 1. So 6 is equal to 1 squared plus 1 plus c. So c is equal to 4. So f of x is x squared plus x plus 4. And what were we asked to find?
F of 2.
F of 2. So f of 2 is 2 squared plus 2 plus 4. And f of 2 is 10.